Okay, so now we're starting chapter 6. This is all to do with polygons again, angles of polygons, distances within polygons, etc, etc. Okay, new vocabulary, not really. You know what a diagonal is, you've used it before. But what's going to happen in 6.1? Well, these two, okay? So you've done the interior angles of a polygon, but now you're going to use a formula to do it. So you can work out, no matter what size polygon you've got, you can tell me or calculate what the total amount of degrees there are within the shape. And from that you can then also find what the exterior angles of a polygon are. Okay, so now we're going to use the polygon interior angles sum. Okay, there is a nice lovely formula that you are going to be using right at the end, but this is a nice investigation. You start off with a triangle and then you increase the number of sides, going up as much as you can, and from one of the vertex you do diagonals. So as you can see, a triangle is one triangle, a quadrilateral is two triangles, 1 and 2. Okay, a pentagon is 3, 1, 2, 3, etc. So as you can see, you know the interior angles of a triangle add up to 180 degrees. So if you count how many triangles are within a particular polygon, at some point or other you're going to be multiplying it by 180. Okay, and if you follow the pattern here, you will see that the number of sides, which is n, subtract 2. So for instance, for the quadrilateral, it's a 4-sided shape. If you subtract 2, that means you're going to get 2 triangles. 2 triangles multiplied by 180, 360. You know every quadrilateral must have 360 degrees. Okay, here's example 1 within your book. As you can see, it tells you that it's a heptagon, which is 7 sides. So n minus 2, which is your 7 minus 2, which is 5. So in other words, you're going to get 5 triangles. 5 times 180 degrees will give you 900 degrees. And if you add together, as they're doing here, all the way inside your triangle, again, you will finish up with 900 degrees. So you know your calculations are correct. Okay, so let's have a look at example 1. Example 1, we've got a decagon. Again, using the same format that you've just been given, which was n minus 2 in parentheses, and you're going to multiply that by 180 degrees. Okay, a decagon is a 10-sided figure, so 10 minus 2 multiplied by your 180 degrees. Okay, so 8 times 180 degrees. Lost it. So 8 times 180 degrees, that should give you 1440 degrees. Okay, example 2. Look for keywords. Keywords in example 2, it's a regular polygon, all right? It must have the same distances from side to side, and your angles must also be the same size as well. Okay, and it tells you, as it says here, that it's a hexagon, 6-sided shape. So here's your formula. Quote the formula. Replace n with 6. So 4 times 180 is 720 degrees. Make sure you always quote the formula. It's worth points in an exam. Okay, look again for this normal clues. All right, the Wonder Wheel at Coney Island in Brooklyn, New York. It's a regular polygon, so all the sides are equal, all the angles are equal. It's a 16-sided. Question this time, what's the interior angle? What's each interior angle, I should say? The problem's still the same as it has been. So you've got your n minus 2 times 180. Okay, it's a 16 side, so 16 take away 2 will give you 14 times 180 degrees. And that will give you a total of 2,520 degrees. That's the total interior, but that's not what the question is asking you. It's asking you what is each angle. Okay, so how many sides has it got? It's 16, not 14, even though you're 14 at this point here, it's 16. So you're going to do 2520 divided by 16, the number of sides, and that should give you 157.5 degrees. Okay, so each angle of that regular 16-sided shape will give you 157.5 degrees. Okay, like in every problem you do in mathematics, there is always an inverse to every problem. Okay, so in this case, what you're telling now is that you are told that the interior angle is 135. This time you've got to find the number of sides. Previously you've been given the number of sides, you've got to find the angle. And as you can see, everything is working inversely. Okay, it says let n equal the number of sides of the polygon, so that will give you 135n. Okay, and then the next one, as you can see, they're doing it in proof right formula for you, so you've written the equation, that's okay. The distributive property, in other words, they're doing n minus 2 multiplied by the 180, which will give you these. Okay, and then just manipulate it around. Okay, so 135 subtract 180n will give you negative 45, and that must equal negative 36. Divide through by negative 45, you get n equals 8. So it's an 8-sided shape. Okay, so using example 3, let's find this. Now this time we're told you in question 6 that each angle is 150. Follow the same pattern as it had in the previous slide. So you've got 150n must equal, and don't forget, here's your formula, n minus 2 times your 180. Distribute out, so 150n equals 180n minus 360. Have you noticed that this part hasn't changed on both sides? You're going to subtract 180 from both sides, 180n, so you've got negative 30n will equal negative 360. You're going to divide through by negative 30, which will give you n equals 12. So to get 150 degrees, you must have a 12-sided shape. Okay, the angle sum theory. Here are 3 different examples of a triangle, a quadrilateral, and a pentagon. But you know me, I've said it many times before, how many degrees all the way around any particular shape. And as you can see, whether it's a triangle, whether it's a quadrilateral, or whether it's a pentagon, the exterior angles must always equal 360 degrees. So here's where your algebra comes into play, and here's example 4. Okay, if you add all the way around, every one of them must equal 360 degrees. Okay, so set it out. As you can see, and what I always do, put it all in parentheses as you go around. That way you don't get mixed up. Collect the like terms together, that's the x values and the constants. And eventually you will finish up with something like 18x equals 360, so x equals 20 degrees. Okay, but don't forget, in example 4 it says find the value of x. You are going to find that same scenario that we've hit so many times. Sometimes it's asking for value of x, which this guy is. Sometimes it's asking you to find the size of the angle. If it is, you know my saying, plug it in. Okay, so here's that same example in question number 8, and again, make sure you check the statement. All we're interested in is the value of x. Okay, so it doesn't matter where you start, but once you start, collect the like terms together. I always start at the top, so I'm going to do 2x plus the 88 plus, and I'll put this in parentheses as I said, x plus 10 plus x plus 2 plus the 52, and don't forget that must equal 360 degrees. Collect your like terms together, so you will finish up with 4x plus 152 equals 360. Okay, basic algebra takes over now, so subtract the 152, so 4x is going to equal 208 degrees, and divide through by 4, so x is going to equal 52 degrees. If you want, it's entirely up to you, but you know what x is. You can put your x back in here, here and here, and then add them all up together to make sure you do get 360 degrees. That little check, worthwhile, because you can always prove your answers correct or incorrect in algebra.